Lesson 7-2, Solving Inequalities by Using Multiplication and Division. And in this lesson, you'll solve inequalities by using multiplication and division. Why is it important? Because you can use inequalities to solve problems involving physical and political sciences. Let's take a look at this connection in physical science. A lever can be used to multiply the effort force you exert when trying to move something. Then the fixed point, or the fulcrum of a lever, separates the length of a lever into two sections: the effort arm, on which the effort force is applied, and the resistance arm that exerts the resistance force. So this is your fulcrum, okay? And this is your resistance arm, and this is your effort arm. Why is it called the effort arm? Because this is where you apply the effort, and the resistance arm because this is where the resistance is. Okay, so in this case, the arrow represents the force being applied, which is down, and the resistance arm represents the force which is being applied after the effort force has been applied, which is up. Okay, so let's continue to take a look at this example. The mechanical advantage of a lever, okay, is the number of times the lever multiplies that effort force. So the definition of a mechanical advantage: the number of times a lever multiplies the effort force. Okay, so your effort force is multiplied. Okay, it's going to be greater. The greater the mechanical advantage. So the formula for determining mechanical advantage of a lever can be expressed by the formula MA for mechanical advantage is equal to LE, which is equal to uh, LE will be your effort arm, okay, and over LR will be your resistance arm, where LE represents the length of the effort arm and LR represents the length of the resistance arm. Okay, so the formula for determining the mechanical advantage of a lever can be expressed as MA is equal to LE over LR, where LE represents the length of the effort. I read that already. Okay, effort arm and represents the length of resistance arm for LR. Okay, so let's continue here. Suppose a group of volunteers is clearing hiking trails at Yosemite National Park. They need to position a lever so that the mechanical advantage of at least 7 is achieved in order to remove a boulder from blocking the trail. That means a mechanical advantage of 7 means that your effort force is being multiplied 7 times. Okay, so even though you're exerting not a lot of force, okay, with a mechanical advantage of 7, the force that you're exerting will be multiplied 7 times. That's what it means. So the volunteers place the lever on a rock so that they can use the rock as a fulcrum. So this is your fulcrum right here, okay, and this is your resistance, the big rock. Okay, they will need the resistance arm to be 1.5 feet long so that it is long enough to get under the boulder. What should be the length of the lever in order to move the boulder? So again, they will need that resistance arm to be 1.5 feet long, okay, because that is the length. Let me show you what that means. So from here to there, that's your resistance arm, and this is your fulcrum right here, okay. So this becomes your LR, okay, and this one, since that's the fulcrum, from there to there, okay, will be your LE, okay. The length of the effort arm, this is the length of the resistance arm. What should be the length of the lever in order to move the boulder? Okay, so let's analyze this problem. We need to find the length of the effort arm to find the total length. Okay, so let LE represent the length of the effort arm. We know that 1.5 feet is the length of the resistance arm. Since the mechanical advantage must be at least 7, we can write an equality using this formula. Okay, so this is, let me just label it for you. This is 1.5, okay, 1.5 feet. This is what we want to find out right here, okay, and we have a mechanical advantage which should be at least 7, okay. So I just put an equation there because we're going to find out later on what inequality we're going to be using for that, okay. Remember the word at least, okay. So moving on. We know that the mechanical advantage is at least 7, so the inequality should be greater than or equal to 7. So in this case, our inequality should be at least greater than or equal to 7, and the formula is LE over LR equals, is greater than or equal to 7. Sorry, I'm reading it wrong. It should be L sub E over L sub R is greater than or equal to 7, and we replace MA with LE or L sub E over L sub R. Okay? And from there, we substitute L sub R with 1.5. So you now have L sub E all over 1.5 is greater than or equal to 7. And we simply solve for the inequality. Okay? And we will solve this example. We will solve this problem in example 1. Okay? So remember this inequality, L sub E all over 1.5 is greater than or equal to 7. Okay? So if you were solving the equation LE over 1.5 equals 7, you would multiply each side by 1.5. You know this using the properties of equalities, multiplication and division properties of equalities. Will this method work when solving inequalities? So before answering this question, let's explore how multiplying or dividing an inequality by a positive or a negative number affects the inequality. Let's consider the inequality 10 less than 15, which we know is true. Okay, so if we multiply by 2, okay, 10 less than 15, we end up with 20 less than 30, which is still true. So basically, we multiply both sides by 2. Okay, if we divide by 5, okay, we divide both sides by 5 in 10 less than 15. We know that 10 over 15 is less than 15 over 5, which is 2 less than 3, which is also true. Okay, now look at now if we multiply by negative 2. If we multiply by negative 2, the inequality, we end up with an inequality negative 20 less than negative 30, which is obviously false, because negative 20 is not less than negative 30. It's quite the opposite. Okay, but the true statement is negative 20 is greater than negative 30. So what did we do to our inequality symbol? From a less than, we switched it to a greater than. Okay, let's take a look at if we divide both sides by negative 5. If we divide 10 less than 15 both sides by negative 5, we end up with a false statement again, because negative 2 is not less than negative 3. On the contrary, negative 2 is greater than negative 3. Again, if you notice, from a less than sign, we switched it to a greater than sign. Okay, if we multiplied or divided both sides by a negative number. So what do these examples suggest? Okay, if each side of the true inequality is multiplied or divided by the same positive number, the resulting inequality is also true. Okay, if the inequality is multiplied or divided by the same negative number, the direction of the inequality symbol must be reversed, so the resulting inequality is also true. So let's summarize this multiplication division properties for inequalities for numbers a, b, and c. Okay, the following are true. If c is positive and a is less than b, then a times c or ac is less than b times c or bc, and a over c is less than b over c. And if c is positive and a is greater than b, then ac is greater than bc, and a over c is greater than b over c. Okay, and the second part, which is this part, okay, of our rule will be, if c is negative and a is less than b, then ac times is greater than bc, and AC is greater than BC. If you notice, the inequality now has been reversed. And if C is negative and A is greater than B, then AC is less than BC, and A over C is less than BC. Again, if you notice, the inequalities here have been reversed. Okay, so from greater than, it becomes less than. Okay, so these properties also hold for the inequalities involving less than or equal to and greater than or equal to. So these inequalities will hold true with those as well. Okay, let's take a look at example number 1 and see how this works. Refer to the connection at the beginning of the lesson. What should the minimum length of the lever be? Okay, going back to that example, let's go back to our inequality, which is L sub E over 1.5 is greater than or equal to 7. We want to solve for L sub E, so we need to multiply both sides by 1.5, and multiplying each side by 1.5, L sub E is now greater than or equal to 10.5. So the effort arm must be at least 10.5 feet long. Okay, in order to find the length of the lever, add the lengths of the effort arm and the resistance arm. The lever should be 10.5 plus 1.5 or 12 feet long. So to be able to get a mechanical advantage of 7 or greater, you need to have a lever that is, you need to have a piece of wood or a piece of stick that is 12 feet long, okay? And you need to have your resistance arm at only 1.5 feet, okay? And the fulcrum in between. All right, let's take a look at example number 2. We have the inequality x over 12 less than or equal to 3 over 2, okay? We want to solve for x. That means we want to undo, okay, 12, okay, and since 12 x over 12 is a division operation, we undo 12 by multiplying each side by 12. First we copy the problem, then multiply each side by 12. We end up with, okay, x is less than or equal to 18. Since we multiplied by a positive number, if you notice, the inequality symbol stays the same. Okay? The solution set, therefore, in set builder notation would be x such that x is less than or equal to 18. Okay, let's take a look at example number 3. Oh, not 4, 3. Since dividing this is the same as multiplying by the reciprocal, there can be two methods to solve an inequality that involves multiplication. We want to solve negative 3w is greater than 27. Okay, let's solve this using method 1. In method 1, we copy the problem, negative 3w greater than 27, and then we divide each side by a negative 3 to isolate w. Okay, and if you divide both sides by a negative number, what you notice that we reverse the order symbol. And once the order symbol has been reversed, we find the value of w to be less than negative 9. Okay? In method 2, negative 3w greater than 27. Okay? In method 1, we divided both sides by negative 3 to undo negative 3. In method 2, we multiplied both sides by negative 1/3. Okay? And still, we reverse the inequality symbol because we're multiplying both sides by a negative number. And the result is still the same. W is less than negative 9. Okay? Now, if you notice, dividing by negative 3 is the same as multiplying by negative 1/3. So when you divide by negative 3, it's also the same as multiplying by negative 1/3. Okay, and checking our equation, or our inequality, we want to find a value that's less than negative 9. Okay, so let w be any number less than negative 9. And negative 3w greater than 27 is our inequality, and the value that we chose to be less than negative 9 would be negative 10. So let's see if negative 3 times negative 10 is it greater than 27, and it is true. Okay, so using set builder notation, Okay, numbers less than -9 compose a solution set. Solution set is W such that W is less than -9. Okay, let's take a look at example number 4. Angelica Moreno is a sales representative for an appliance distributor. She needs at least $5,000 in weekly sales of a particular TV model to qualify for a sales competition to win a trip to the Bahamas. If the TV sells for $250 each, how many TVs will Miss Moreno have to sell to qualify? Again, here, when you're reading it, you need to be very mindful of the phrase "at least $5,000." The word "at least $5,000" indicates an inequality of greater than or equal to. Okay, so let's see what we have. Let T represent the number of TVs to be sold. At least 5,000 means greater than or equal to 5,000. The price of one TV times the number of sets sold must be greater than or equal to the total amount of sales needed. That's what we want to do. Okay, so the price of one TV is $250. Okay, multiplied by the number of TVs sold, which is represented by the variable T, will be at least $5,000. So solving that inequality, we want to solve for T. That means we divide both sides by 250. Okay, we end up with T is greater than or equal to 20. So this means that Miss Moreno must sell a minimum of 20 TVs to qualify for the contest. So to check this answer, the amount of money from the sale of 20 TVs would be 250 times 20, or $5,000. Let's finally go to the last example, example number 5, before we go to example number 5. Okay, the secret word for this particular lesson would be 49ers. Again, 49ers will be the secret word. Triangle XWZ is not an acute triangle. The greatest angle in a triangle has a measure of 6D degrees. What are the possible values of D? Okay, so this is again an inequality problem. Okay, triangle XYZ is not an acute angle. The greatest angle, okay, the phrase greatest angle indicates that it should not exceed that angle, has a measure of 6D. What are the possible values of D? So since triangle XYZ is not acute, the measure of the greatest angle must be 90 degrees or larger, but less than 180 degrees. Thus, 6D should be greater than 90 degrees, and 6D is less than 180 degrees. Okay, so we have 6D is greater than or equal to 90 degrees. Let's solve that inequality first. And then we divide both sides by T. We end up with D is equal to greater than or equal to 15. Okay, and let's look at the next inequality. 6D is less than 180. Okay, divide both sides by 6. We end up with D is less than 30. So the value of D must be greater than or equal to 15, but less than 30. Okay, so that's how you use solving inequalities to solve problems such as this one. What is also assumed in this problem is that you know the definition of an acute angle. Okay, an acute angle must, when you talk about an acute angle, the measure must be not an acute triangle. So that means if it's not an acute triangle, the measure of the greatest angle must be greater than 90, but less than 180. Okay, so that's the measure of an obtuse angle. So an obtuse triangle should have an angle that is greater than 90 but less than 180. So that is the assumption in this particular word problem. Okay, meaning to say everything that we learned in the past should come into play. Okay, and that's the end of our lesson. Thank you for watching. Before I sign out of this, Okay, like what I've been telling you, do some problems on your own. Okay, do the odd numbers. See if you can answer the odd numbers. Okay, see if you get this lesson. Okay, the answers, of course, of the odd numbers are at the back of the book. Check to see if you got them or not. Thank you for watching. Gutom ka?